Assalamualaikum warahmatullahi wabarakatuh. We are from Group E, and this is our final project. We are designing single rail power supply and Class AB audio amplifier. My name is Ahmad Zaki Jamaluddin.
My name is Courage Yekti.
My name is Kevin Pradipta.
My name is Sylvia Najla Zahira.
Today we're presenting our project about the speaker, and this is our power supply, and this is our AB amplifier, and this is our speaker. So we can start by pressing play on the Spotify song, and it will be outputted into this 3.5mm jack. If we play, the speaker will have a sound, and then on the potentiometer, if we turn it to the right, the audio will be gone, and if we turn it to the left, the audio will increase. And if we unplug the power supply, the audio will disappear. So
Okay, so this is basically the project overview. We are making a power supply, and then the power supply will be give power to the amplifier circuit. So to get the audible sound from a speaker output, the input is from 0.5mm jack from the laptop, and then processing with the amplifier circuit, and then the output is 8 ohm speaker.
now for the project objective. So all we want is first is to have a fully functional power supply, or just an AC step down to 12 volt, and then the 12 volt AC turns into DC to a single rail. And then for our speaker is just to design a audio amplifier. So that's what the power supply is gonna be powering. It's just an AB amplifier. So to make sure that the audio input from the phone is audible to the speaker. Next slide.
Okay, so here are all our components. And to understand this, we kind of need to look at the circuit for a bit first. So for a brief explanation, here is the power supply. It's just a basic single rail configuration. And this will power our amplifier circuit. We have the amplifiers, op-amp stage, we have the AB stage, AB amplifier stage, and we have the output. And this is a simulation of what the output looks like. Even though it does look a little distorted, it's kind of fine in real life. So all the specific parts and components are in here. If we look at the power supply, it's these step-down transformer, rectifier, capacitor, and the voltage regulator. And then we have the actual amplifier part, which is all of these. Preamp is this part. And the specifics you can see in the report, and we will explain more on actually later.
Okay, so this is our working principle. So there is 5 stage of the working principle. The first of all is the power conversion from the power supply. Basically step down the alternating current from the wall and to 12 volt, and then the power supply will be moving to signal input and occurs a pre-amplification, and then move to the coupling capacitor, and from the coupling capacitor will be moved to the class AB power stage, and lastly it will be output to the speaker. So for the power conversion, it converts the high voltage alternating current wall power into usable energy. So there is a few components. The first one is a transformer. It is a step down transformer. Second one is the rectifier bridge diode. The third one is the regulator to create a 12 volt DC power supply, which is to run the circuit, and then the capacitor to make the direct current more smooth. And yeah, this is on the right picture, there is our first attempt to build the power supply, and it works on 11.95 volts from the 20 volt step down into 12 volt. So from Jesse, can you oh, how do I yeah, basically like the yellow one is the ground, the blue one, the blue wire from the trafo is the 12 volt. So it transfer into the diode rectifier and then move to capacitor, and capacitor move to voltage regulator. And then there is an LED to indicating that the power supply was working properly.
All right, so now onto the actual amplifier circuit. So our small input from the aux, it goes to the op amp first, and this might look familiar because it is actually the non-inverting op amp configuration. As you can see here, I will hold on. It's basically just this, and you can calculate the the gain that you get from this formula. But instead of using a resistor for R2, we use a potentiometer, so you can control how much the resistance is. And in this case, we use a 50K ohm potentiometer. So the higher the resistance is, it'll be louder, because if we look at the formula right here, the higher the resistance is, the higher the gain because of RF over Rn. And that's basically how it works. And then the output will go into the next part, which is the coupling capacitor.
So next is the coupling capacitor. It's like it's used to block the unwanted DC voltage, while allowing the AC audio signal to pass through. This actually like helps protect the speaker from the DC current, and like it's ensure only the amplified audio signal reaches the output stage.
Now, this is the class AB power stage. There is supposed to be two. So the first Q1 and Q2 is technically the diamond, and then the second one is the push and pull. So the first one is just to amplify the very, very low voltage, and it increases since the Q1 is lower than 0.7 and the Q2 is above 0.7, but it's around that. It's gonna be equivalent to like 1.4 volts, and then it's gonna be detected by the next base, which is gonna push and pull the voltage and the audio to have at least an audible audio without it stuttering, unlike a class B push and pull.
Now is the last one, so it's the output speaker. So the speaker is act like as the final output of the system by it converting the amplified electrical audio signal into the sound waves. So the amplified signals from the class AB amplifier is delivered to the speaker to produce clear audio output. The next.
So this is our PCB for power supply and amplifier. We are making this PCB on KiCad software. So this is like basically the exact same thing from the circuit that we've explained before, just translated into a PCB model. So for the power supply, there is a terminal block, the green one here, the capacitor, the resistor, rectifier, voltage regulator, and on the right side there's an amplifier PCB. So this is like there is a capacitor, the jack audio, the amplifier is the circuit, so the tip 31 to tip 32. So this is overall our PCB.
Okay, so that's all from our presentation about the single rail power supply and Class AB audio amplifier project. We hope this presentation explained the design, the working principle, and performance of our system clearly. Thank you.